Hello, welcome to Backer Breaks It Down. In this lesson, we're going to apply coordinates to find area using the boxing method. So basically, if you take a look at this example here, we all know you can find the area of a triangle by multiplying 1/2 times the triangle's base times the triangle's height. Now, I can easily use distance formula to find the base of my triangle, but what is the height? So we have this method called the boxing method. And the boxing method involves sketching a rectangle, and you basically want to frame the entire figure in the rectangle, but you want each side of the rectangle to pass through each of the vertex. And then we simply calculate the area of the rectangle. All right, so I'm going to do that here. And I'm going to draw a rectangle so that it passes through all three vertices. And then I need to find the area of this rectangle. Now, whenever you're working on the coordinate plane, please look at the axes to see what the scale is. Like here, they're counting by threes. So area of a rectangle is equal to base times height. Whoa, okay. So I need to figure out what is the base and height of my rectangle. So the base goes from -12 to 15. So that means it's 27 units long. And for the height, it goes from -6 to 18. So that's 24. So I want to multiply the base and the height, 27 and 24, and get the area of my rectangle. All right, which apparently I've already done. I got 648. So I'm going to go back here. So after you find the area of your rectangle, the next thing that you should realize is that there are all these different right triangles. So let me just like highlight them for you. All right, so you've got this triangle right here. Okay, and this one. And then, of course, this one. And they're right triangles. So it's going to be really easy for us to find the area of each of those right triangles, you know, because area of a triangle is half the triangle's base times the triangle's height. So this is a much better illustration and diagram. So triangle 1 has a base of 18 and a height of 24. Triangle 2 has a base of 9 and a height of 15, and triangle 3 has a base of 27 and a height of 9. So I'm going to go and I'm going to find the area of all three of those using my formula for area of a triangle. Look at how fast I did that. Okay. So the area of triangle 1 is 108 square units, triangle 2 is 67.5 square units, and triangle 3 is 121.5 square units. So now we're ready to find the area of the original geometric figure. Okay, and I'm going to do that by simply subtracting the sum of the areas of the right triangles from the area of the rectangles. So I do need to like figure out like what is the sum of those. And then I can go 640 minus that to get the area triangle TUV. And I thought I had already done that. And I don't have a calculator. You get the idea, right? Because I don't have a calculator on me. Sorry about that. Anywho, that's how you would find the area of that triangle there. So the boxing method, we start by using a rectangle to box in the figure, and we calculate the area of the rectangle. And then we find the areas of each right triangle formed, and we subtract these from the area of the rectangle to get our final answer. And that's how Backer breaks it down, the boxing method.